Hello everyone. I hope you all might have seen my previous video, that is trigonometric identities. By now you all might have had a good idea about what is trigonometric identities, the concept and the way we need to use the formula in different forms. Today we are going to learn about how to solve certain problems like short answer type questions as well as essay questions related to trigonometric identities. Now let's get started. Our first problem is cosecant theta minus cot theta whole square. We need to prove that it is equal to 1 minus cos theta by 1 plus cos theta. By seeing on LHS side, we can just recollect that it is in the form of a minus b whole square. So let us start using a minus b whole square. Suppose this is a and this is b. I can apply a minus b whole square, which is equal to a square plus b square minus 2ab. So I am starting with a minus b whole square and taking this LHS side. A square is cosecant square theta. So I will write it as cosecant square theta plus cot square theta. B square is cot square theta minus 2 cosecant theta cot theta. Now try to change it in the form of 1 by sine. So we will take it as 1 by sine square theta plus cos square theta by sine square theta minus 2 1 by sine theta into cos theta by sine theta. Steps: sine square theta and sine square theta. Further, for clarification, I will write an extra step. Sine square theta plus cos square theta by sine square theta minus 2 cos theta by sine square theta. Now these all are like fractions, so I can take sine square theta as denominator. This is in the form of 1 plus cos square theta minus 2 cos theta. Again apply a square plus b square minus 2ab form. So if I use the formula a square plus b square minus 2ab is nothing but again a minus b whole square. So I will get back this numerator into 1 minus cos theta whole square. So let us see. Here we will be getting it as 1 minus cos theta whole square by sine square theta. We know the identity as sine square theta is equal to 1 minus cos square theta, which can also be written as 1 square minus cos square theta. So sine square theta can be written as 1 plus cos theta and 1 minus cos theta. So let us apply this one in the denominator, and numerator will be same. Numerator is, as we know, this is whole square. Whole square means a square is equal to a into a format. So we will be writing this one 2 times. 1 minus cos theta, again 1 minus cos theta, as it is in whole square format. And what is sine square theta? 1 plus cos theta and 1 minus cos theta. When we cancel 1 minus cos theta, 1 minus cos theta, our answer will be 1 minus cos theta by 1 plus cos theta. Hence this is RHS. Therefore LHS is equal to RHS. In this way you are going to solve the problem. Pause the video, have a look, practice 2 times, then we will move on to the next question. Our second problem is show that root over 1 plus sin theta by 1 minus sin theta is equal to secant theta plus tan theta. This question appears to be little different, but actually if you observe carefully, this is similar to your previous question. If root is there, we will solve it in rationalizing format. Let us take rationalizing factor as is 1 plus sin A. This one we will be selecting according to the denominator here. As the denominator is 1 minus sin A, we write it as 1 plus sin A. So I am taking LHS side, root over, write the question as it is, 1 plus sin A by 1 minus sin. And with rationalizing factor, you are going to rationalize 1 plus sin A by 1 plus sin A. Now we can see very clearly that 1 plus sin A, 1 plus sin A. So we can take it as 1 plus sin A whole square by A plus B, A minus B formula. So I can take it as 1 square minus sin square. Now you can mention the formula here, A plus B and A minus B is equal to A square minus B square. Compulsorily whenever you are taking any step, you are supposed to mention the formula. Now this one, 1 minus sin square theta is our sin square theta plus cos square theta is equal to 1, where I can write cos square theta is equal to 1 minus sin square theta, our first identity. So instead of 1 minus sin square theta, we will be using cos square theta. 1 plus sin A whole square by cos square A. 1 minus sin square is written as cos square A. Now, as square is there on numerator and denominator, we will be taking it as whole square. So we write it as root over 1 plus sin A by cos A whole square. By now I hope you got an idea how to proceed further. Now cos theta can be taken separately for 1 and sin. So 1 by cos A plus sin A by cos A. This is equal to 1 by cos is nothing but secant A plus sin by cos is tan. This is RHS. Therefore, LHS is equal to RHS. Many times in essay 1 and essay 2. Now, by seeing the problem, I hope you all got an idea how to proceed with the problem. So, we can first start with A plus B whole square, which is equal to A square plus 2AB plus B square. So, we are going to expand both the terms, that is sin square A plus 2 sin A cosecant A plus cosecant square A. This is a one, that is cos square A plus 2 cos A secant A plus secant square A. Now we can understand very clearly that sine and cosecant both are reciprocal to each other, so it becomes 1. And cos and secant both are reciprocal to each other, so this becomes 1. This one and this one. Now let us rewrite the step again. Sin square A plus 2 into 1, or you can take an extra step, that is sin A and 1 by sin A, as they are reciprocal to each other, plus cosecant square A plus cos square A plus 2 cos A 1 by cos A plus secant square A. So we can cancel cos A here, sin A here. 2 plus 2 is 4. So we'll be writing it as 4, and we can combine sin square theta plus cos square theta. According to that one, we can combine this one and this one. Sin square theta plus cos square theta is 1, our first identity. So 1 plus 2 plus 2 is this 2 and this 2 is 4. Now left over is cosecant square A plus secant square A. Now this is 1 plus 4 is 5. Cosecant square A is nothing but 1 plus cot square A, because we know the identities. Identities are 1 plus tan square A or tan square 1 plus tan square theta is equal to secant square theta, and 1 plus cot square theta is equal to cosecant square theta. Apply this one here. So we are going to get it as 1 plus 4 is 5 plus 1 plus cot square A plus 1 plus tan square A. Now 5 plus 1 is nothing but 7 plus, I can write tan square theta first because on RHS side it is tan square theta. So tan square A plus cot square A, which is equal to RHS. Therefore LHS is equal to RHS. Hope it is clear. Please pause the video, give a try so that you can practice immediately. Let us solve this problem. LHS is 1 plus secant A. I will write it as 1 plus secant A can be written as 1 plus 1 by cos A by 1 by cos A. With this, the next step will be cos A into 1 is cos A plus 1 by cos A, and denominator is 1 by cos A. When we get fraction by fraction, we write the reciprocal for second one. Cos A plus 1 by cos A into this cos A comes in the numerator and by 1. We can just cancel cos A and cos A. We are left over with cos A plus 1. Now we need to get this RHS. So we will be multiplying and dividing by this one I can write it as 1 plus cos A to make it easy for us, by nothing is there, so 1. I'm multiplying and dividing with this one, so 1 minus cos A by 1 minus cos A. Now A plus B, A minus B formula. A plus B into A minus B is equal to A square minus B square. By applying this formula in numerator, we get it as 1 minus cos square A by 1 minus cos A. We know the identity sin square theta is equal to 1 minus cos square theta. So 1 minus cos square theta will be written as sin square theta. So it is sin square theta by 1 minus cos A. Sin square, so sin square A by cos 1 minus cos A, which is equal to RHS. Therefore LHS is equal to RHS. Hope it is very simple and easy. This has come in your previous exams for 4 marks. So try to learn. Else we also have many methods, but this is one of the method. It can be proved LHS separately and RHS separately. You will be getting same answers. You can show it as LHS equal to RHS. Else solve it like this. secant theta plus tan theta equal to p, and we need to prove that sin theta is equal to p square minus 1 by p square plus 1. This problem has many methods, but the most favorite method of students is by using identity. Secant square theta minus tan square theta is equal to 1. Our second and third identity is a square minus b square format. We can write this one as a plus b secant theta plus tan theta, and a minus b, that is secant theta minus tan theta, is equal to 1. If this one is p, this implies this p goes to the other side, then it becomes secant theta minus tan theta is equal to 1 by p. Very important. We'll take this one as first one, given as first one, and this one as second one. We are going to solve it as 1 plus 2. That is secant theta plus tan theta is equal to p, and secant theta minus tan theta is equal to 1 by p. It's very simple. As we are adding it, this gets cancelled. So 2 secant theta is equal to p plus 1 by p. So 2 secant theta is equal to p square plus 1 by p. Get this 2 here. Secant theta is equal to p square plus 1 by 2p. Now let us take this one as a. Now let us solve 1 minus 2. Same, secant theta plus tan theta is equal to p, and secant theta minus tan theta is equal to 1 by p. But this time we are subtracting. So this becomes plus, and this gets cancelled. So tan plus tan is 2 tan theta is equal to p, and this is minus p minus 1 by p. So p minus 1 by p is nothing but 2 tan theta is equal to p square minus 1 by p. In other words, tan theta is equal to p square minus 1 by 2p. Now let us think this is b. Now we are going to take the help of a and b. Tan theta by secant theta is sine. Always remember. So we will be taking it as tan theta by secant theta. So if I write it as tan is p square minus 1 by 2p by p square plus 1 by 2p. This is sine theta. 2p gets cancelled. P square minus 1 by p square plus 1. Hence proved. Thank you.